Hi everyone, welcome to the Apply Yourself channel. In this video we'll be discussing probability theory. And probability theory is a fundamental aspect that underpins virtually every topic or research area in data science. This video is going to be divided into two sections. In the first section we're going to have a concepts walkthrough, and this is where we'll discuss some basic ideas and concepts surrounding probability theory. And these are really just simple ideas, there's nothing too complex about them, but regardless, in any case, they always remain very useful in real-world application. In the second section, we'll be applying logic and intuition. Essentially, we'll be applying the theory we have learned in the concept section to a real-world data set with logic and intuition, so that we can estimate probabilities of random events selected from that data set. Now, as you can see from the icon on your screen, as you can probably see from the icon on your screen, we'll be using Python, and that's because Python is the in-demand programming language by data practitioners in the field of data science. So with that out of the way, let's get on with the rest of the video. Let's talk about uncertainty, because you can't discuss probability without uncertainty. And uncertainty is the problem probability theory solves for us, or at least attempts to solve for us. So what is uncertainty? It is simply the dilemma of decision making with incomplete information, which is the way we operate in the world. That's all uncertainty is. Uncertainty is the problem of making decisions when you don't have all the information you need. So, what is probability theory? Probability theory is a field of mathematics that gives us the language and the tools we need to quantify the uncertainty of events. So, what is the probability of an event? Probability is simply a measure that quantifies the likelihood that an event will occur. And as you can see on your screen, I have 3 different examples of events we could quantify probabilities for. So we could want to find out the probability of a flood happening in your region on a particular day. We want to find out the probability of a candidate winning an election. We could also want to find out the probability of the stock market either going up or going down on a particular trading day. Now what you have on your screen is the mathematical representation for the probability formula, which is simply just the occurrences we are looking for divided by the number of non-occurrences and occurrences, the sum of the non-occurrences and occurrences. Now note that the non-occurrences and occurrences together make up the entire sample space. This is also an alternative formula that says the same thing with the previous slide. So essentially it is the desired outcomes, the outcomes we're looking for, we're expecting, divided by all the possible outcomes in the sample space. Now, most times data practitioners typically work with multivariate data sets, and these are data sets with more than one variable or one column. And if you're given a data set, every row in the data set will represent a separate observation in the data set, and every column will represent a separate random variable. Now, these variables typically interact in different ways. They could be correlated to varying degrees, and the correlations could either be positive or negative. And these resulting interactions will impact their probabilities. And these interactions can be simplified, because of the purposes of this video, for illustrative purposes, by reducing the intuition to just 2 variables. So for illustration purposes, we'll just be using a data set with 2 variables to explain the concept in a simpler way. That means we'll introduce the probability of multiple random variables as the probability of event A and event B. So that means random events in variable X will take on event A, and random events in variable Y will take on event B. So what are the 3 main types of probability we want to consider? Number 1, joint probability, which is typically the probability of 2 events occurring simultaneously. For example, the probability of having a flood and a bear market in the stock market on the same day. Now the key word to know here is and, because anytime we say and, we're looking at the probability of those 2 events occurring at the same time. That's why the word used there simultaneously. But what's the probability that both those events will happen at the same time? A second kind of probability we would always come across is marginal probability, and this is the probability of an event regardless of the outcome of other variables. So essentially it is just the probability of a single event. And the key word to note there is regardless. So regardless of what might happen in another variable, we want to know what the probability of an event in a certain variable is. And the final type of probability to be familiar with is conditional probability. And that's the probability of one event occurring in the presence of one or more other events. So, given we have an event in variable y, what is the probability of getting a particular event in variable x? And the keyword there to note is given. Now, there are two main approaches of thinking or interpreting probability, and the two main approaches we have are the frequentist probability and the Bayesian probability. Now, the frequentist approach typically considers probability as the actual likelihood of an event, and that's because events are observed and counted, and their frequencies provide the basis for directly solving the probability of that event. So in a sense, we can say the frequentist approach is empirical because it makes use of data from past events to quantify the probability of future events. But the Bayesian probability, on the other hand, assigns probability based on personal beliefs about a certain event. It's not based on empirical data, it's just based on hunch feelings, gut feelings of whoever it is that's trying to ascertain the uncertainty of a particular event. Our goal in this video is to illustrate the frequentist approach, considering its empirical nature, like I said, and its extensive use of data. So, with that said, let's get on with the rest of the video and move on to the logic and intuition section. So, this is the logic and intuition section of the video. If you happen to need access to the notebook we'll be using for this section and the data set we use for this section, I am going to upload it on the GitHub page, and I will leave the link or the address of the GitHub page in the description box directly below this video. So if you need, like I said, if you need access to this notebook and the data set, I'm going to make it publicly available on my GitHub page. The data set itself comes from the Lending Club, which is a US-based institution that provides loans to its members. That's as much as I know about them. And I don't know if there are any more publicly available data sets they might have, but for those who might be interested in more data sets from them, this is as much as I know that they have publicly available. But obviously you're welcome to do your research and, possibly find more data sets. I hope that works out for you. Anyways, let's go ahead. So the first thing we're going to do here is import pandas. Pandas is the key Python library for manipulating and navigating. I don't know about navigating, but I know it's the key library for manipulating data frames or data sets. So let's go ahead and, as you can see, I've written the code in the code cell. So let's just go ahead and activate that code cell. There you go. Pandas has been activated. So the next thing we're going to do is load the data set, save it in a variable, and return a snapshot of the data set, which is basically just the first 5 rows of the data set. So again, like I did with the first code cell, I have written the command in this second code cell, and we'll just go ahead and run it. There you go. Let's take a look at some of the columns. As you can see, it's a very extensive data set. I'm not going to waste your time, explaining the details of this data set. You're welcome to go through it when you download the data set from GitHub. Let's grab the columns and see what information this data set has. Those are a lot of columns, as you can see. Again, you're welcome to go through when you download the data set on your own. But like I said in the concepts walkthrough, we're only interested in 2 variables, 2 columns, because the concepts we'll apply on these 2 columns are just as applicable to a data set with more columns. It doesn't matter what number of variables or columns you have in the data set. The logic is still, that's why I call it logic and intuition, because it's still the same basic logic and intuition for any kind of data set. So the variables I have selected for this section of the video are just the loan amounts of the borrowers and their revolving balance. So let's go ahead and just grab that and be sure, since I've written the code in the code cell, let's be sure the code runs properly. There you go. We can indeed confirm that the code runs properly. So we have the loan amounts and the revolving balance. I'm also going to upload the abridged version of this initial data set here. So this data set here will also be converted to a CSV file and uploaded on the GitHub page for those who might be interested in that too. Now, before we go ahead, let's take a few seconds to just break down probability logic. We need 2 things. Number one, for any probability question we're trying to solve, we need the frequency of the desired outcomes of the events that we're trying to solve, and we need the number of all possible outcomes. That's it. Once you can solve for those two figures, you can solve any probability. So let's look at joint probability. Let's start with joint probability, which is the probability of two events occurring simultaneously. And we have a practice question here. It says, what is the probability of selecting a borrower with a loan amount at or below 10,000 and a revolving balance at or below 20,000? So let's go back to the logic. What do we need? We need the frequency of desired outcomes. What is the desired outcome we're looking at here? What is the event we're looking at here? It's simply borrowers with a loan amount at or below 10,000 naira. And remember, the key word I said was and in the concepts walkthrough. Simultaneously means two events happening at the same time. So we have event A and event B happening at the same time. What is event A here? Event A here is a borrower with a loan amount at or below 10,000 naira. And event B is a borrower with a revolving balance at or below 20,000 naira. So let's go ahead and grab the frequency of this event from the data set. So what we need to do, this is not a Python tutorial, but anyone who's familiar with the Python language can make sense of the code I'm typing here. The logic is more important than the code. This is not a coding lesson at all. I just want you to get the logic. So what we're about to do now is get the number, the frequency of all the borrowers who fit this criteria. And what is the criteria? A loan amount at or below 10,000 naira and a revolving balance at or below 20,000 naira. So let's go ahead and get that. It's always nice to put your events in parentheses. It makes the code readable. So the first criteria is a loan amount. I need to make sure I get the spelling right. So the code, we don't get an error when we run the code. So we need the loan amount to be at or below. So it's either equals to 10,000 or below 10,000 naira, which I've done with the symbol, the less than and the equals to sign. 10,000. And then we also need borrowers with a revolving balance at or below 20,000 naira. So that means they either have a revolving balance of 20,000 naira or below 20,000 naira. So now that we have that, we can grab the frequency by using the inbuilt Python function called length. So what length is going to do is it's going to count all the instances of borrowers that fit this criteria. And then we can store that in a variable called our desired outcomes. So we fulfill the first condition, the frequency of desired outcomes. Now what we need now is the number of all possible outcomes. So what will be our possible outcome? Our possible outcomes will be all the borrowers in the data set, which is the length of the entire data frame. Because all the possible borrowers we could pick, let's pretend all the borrowers were inside quote unquote a bag or a box, or we had their numbers inside a bag or a box. Everyone we could pick will be inside that box, and that would include people that fit the criteria and people who didn't fit the criteria, which is what the possible outcomes is. I remember we made the small notes when we went through the slides that people who fit the criteria and people who did not fit the criteria made up the sample space. So our possible outcomes in this case is everyone in the sample space. Now that we have both numbers, we can go ahead and solve for the probability. So the probability then will be the desired outcome divided by the possible outcomes. And what number does that give us? 37%. So again, back to the logic of having all the borrowers, or let's say we have the IDs of all the borrowers inside a box or a bag. The probability of selecting a borrower who had a loan amount at or below 10,000 naira and a revolving balance at or below 20,000 naira from this box will be 37%. Or we can say the likelihood of finding a borrower inside this data set or inside this box or container of borrowers that fits this criteria is 37%. Let's now solve for the marginal probability. The marginal probability, which is the probability of an event for one random variable, irrespective or regardless of the outcome of another variable. And this is essentially the probability of an event. So it doesn't matter what the values or what the events of another variable throw up. We just need the probability of one particular probability of an event for one particular variable. So essentially what we're looking for is the probability of an event. Let's take a look at the practice question here and see if we can apply the logic and intuition to it. So the question says, what is the probability of finding a borrower with a loan amount of 10,000 naira in the data set, regardless of their revolving balance? So essentially we just want the likelihood or the chance or the probability of finding a borrower that has a loan amount of 10,000 naira. So we'll go back to the logic. What's the desired outcome? A borrower with a loan amount of 10,000 naira. Let's go ahead and find that and grab that and put that in the variable called desired outcome. So loan amounts of 10,000 naira or any other currency of your choice, regardless of where you're watching from around the world. And then we'll grab the number of instances of borrowers that fit that condition and put that in a variable called desired outcome. And this time again, our possible outcomes will be all the borrowers in the data set. Because like we said, if we pretended the borrowers we had the IDs of the borrowers in a box or a bag, and we're selecting borrowers who fit this condition, the number of borrowers in the bag will be all the borrowers in the data set. And we just want to pick out those who fit this criteria. I keep using condition and criteria interchangeably, but the word I should be using here is criteria, not condition, because we're still coming to conditional probability. I'll take the cell out because we don't need it. So if we divide that numerator by all the possible outcomes, what would that give us? We have a 6.9, essentially a 7% chance of finding a borrower with a loan amount of 10,000 naira. So if we selected, again, if we had all the IDs, if we wrote the IDs of the borrowers in tiny pieces of paper, and we put those pieces of paper inside a bag or a box, and we selected just one borrower, the likelihood of that borrower having a loan amount of 10,000 naira will be, give or take, 7%. That's essentially what this figure means. So that would suggest in some way it would be very difficult to find a borrower with a loan amount of, not very difficult, but it was somewhat difficult because 7% is a very, a pretty low probability. You'll be hard pressed to find a borrower with a loan amount of 10,000 naira. I want to be sure I wrote 10,000 here. Okay, I have 10,000, that's correct. Thought it was 100,000. All right, so we now come to conditional probability, which is a little bit, it's not as tricky, but it's a little bit tricky. You have to be very aware of the condition in the event you're solving for. So the conditional probability is simply the probability of an event occurring given the occurrence of another event. So that tells us our number of possible outcomes is going to change slightly. So it won't be the size of all, or the total number of all the borrowers we had in the bag or in our box. It's just going to be the number of borrowers who fit the condition for the event. So let's consider the practice question. What is the probability of finding a borrower with a revolving balance at or below 20,000 naira, given that their loan amount is at or below 10,000 naira? Now the keyword there again, like I said, given. So this will form the size of our possible outcomes, because we're just taking a subset of the original data set, which is borrowers with the loan amounts below 10,000 naira. And from that subset, we're going to find the probability of finding a borrower with a revolving balance of 20,000 naira. Let's go ahead and solve for that. So that means our possible outcomes now, in fact, we're going to have a brand new data set. Let's call this DF_2. And that will essentially be borrowers with loan amounts at or below 10,000. So this is the new basis for the conditional probability we're about to solve. So that means our possible outcomes will no longer be the size of the entire original data set. It will just be the size of this new data set that fits the given condition. So that's the size of DF2. And then our desired outcomes will now be based on DF2. And that means we'll be looking for borrowers with a revolving balance at or below 20,000 naira in this second data frame, because this is the second data frame that fits our given condition. All right, so let's grab that. That will be borrowers in this new data frame that have revolving balances. Is that how to spell that? All right, that's how to spell it. At or below 20,000. So our conditional probability will now be our desired outcome divided by our possible outcomes, which has changed now because of the given condition. All right, so let's see what that figure is. We have an 89% chance of finding a borrower that has a revolving balance at or below 20,000 naira if their loan amount, if given, in the event that, these are all similar ways of phrasing the same thing, given that their loan amount is at or below 10,000 naira. So for the borrowers who have 10,000 naira as their loan at or below 10,000 naira, the borrowers who are at or below 10,000 naira in loan amounts, if you brought them out of the original data set, the probability of finding a borrower within this new size of borrowers that has a revolving balance of at or below 20,000 naira is 89%. And so with that, we have come to the end of this primer, this little primer on probability. Like I said, this notebook and the accompanying datasets will be uploaded on GitHub, and the link will be in the description box below this video. Thank you for watching this video. I appreciate it, and I'll see you next time.